All right, so we're supposed to sketch the graph of a function f such that all the following statements are true. Okay, so we want the derivatives less than 0, so we want negative slopes when we have less than -1. So let's get a coordinates going here. And so -1, let's call that our -1 at that point. So we need negative slopes here. Then we need positive slopes going the other direction. And we can't have a derivative exist at that point there. So it has to be a vertical asymptote at that point there. Okay. Well, if we're going and having negative slopes here, well, this could kind of be something like the opposite of one of the last ones we had. It could look something like that. Then we have to have positive slopes here. So then it's going to kind of come up the other direction here. And then it doesn't exist at that point. So it almost looks like upside down of this one, move it over here to -1. And that's probably what I would do for this graph. That would be the easiest one to draw. And so that would be how I would sketch a graph like that one. So I just knew that I had to have decreasing going that direction, increasing going that direction, and I couldn't have anything equal at the -1. Okay. Now, is there anything else we could do? Um, let's see. Well, we could do. So you always want to think about other things here. Maybe at -1, if we're increasing to the right, we could have something like that. And if we're decreasing to the left, we could have that. And we have that point here. And so at a point, it does not exist. And so that would be another way to do it. So, we could have the smooth curves like this going up, or we could have this pointed curve. It's not smooth, it's pointed. And so there, it would not exist as well. So, the asymptote or the pointed corner, either one of those will give you that does not exist. All right, so now we want to sketch the graph of a function that all the following statements are true. So we have a relative minimum at 3, relative max at -1. It's increasing slope less than -1 but greater than 3. Its derivative is less than 0 for the in-betweens. And at -1 it's 0, and at 3 it's 0 for the derivative. So what do we have here? Let's kind of get something here. Now, we have maybe a point at -1. We have a point here maybe at 3. It's a relative min at x equals 3. So let's just put a dot here. And it's a relative max at x equals 1. So let's put a dot here. How high and how low, that doesn't matter. It doesn't say anything about that. Now it says we have tangents at those points are 0. So we know that's going to be the peak. So that's going to be our relative min and relative max. And so now it says it's going to be increasing less than -1. So increasing means it's going to kind of come down like that. And again, it's probably has more of a curvature, but that's okay because we're doing this kind of piecemeal. And then greater than 3 is going to be increasing as well. So then it's going to be something like that. Now it says it's going to be decreasing between -1 and 3. Well, we know that that's the peak. So it's going to be coming down and coming down, and then it's going to start going back up again. So that will look something like it. We have negative, 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 positive, positive, 0, 0. So we fit all of those things. There's a relative min at 3, a relative max at -1. So I think it all fits. Again, maybe you could draw a smoother curve or something like that, but it's going to look something like that. There's not much else we can do as far as of what those are, because if we put in extra points here, then there's going to be extra minimums and maximums, which it doesn't say there are. And it's saying it's always going to be decreasing on that interval. So it has to do something like that. And so that would be how I would draw that one. Again, I don't know if there's another way I could draw that one. That one just seems to be like the only one. All right, so let's pause there and come back for more.